Here we have a number of capacitors that I want to show you. This is a capacitor of about half a millifarad, which is basically about 400 microfarad, pretty big size. Here I have a number of so-called supercapacitor, and this one, very small one, which we are going to use for demonstration, is 10 farad itself, a very small capacitor with a fair amount of capacitance. I also have 100 farad capacitors, and this is a 1000 farad capacitor. Now, you can find capacitor in a lot of electric circuit. For example, what we have here is a power supply for batteries, power to battery, for which you would find these are capacitors on the circuit board to protect the battery from surge of electricity. So what we're going to do now is to look at how we can charge up a capacitor. So we're setting the voltage to 2.5 volt, and so we're going to, at this point here, connect that to the other side, and you can zoom in gradually and see on the oscilloscope here, you can see that it's rising up, and 1 square on the oscilloscope corresponds to 5 seconds. And so it started from a voltage of 0 and rising to a saturation of 2.5 volt. So we have here a capacitor of 10 farads connected to a resistor that is 1 ohm. So the RC time constant would be equal to 10 seconds. So what you see here is that it's saturating, the capacitor is being charged up, it's tending to saturation at 2.5 volt, and it's already up to saturation. Now if we take this off, you'll see that it starts to discharge, the capacitor starts to discharge, and again you would have a discharge time scale, RC time constant, of 10 seconds. So in about 2 of those squares, you'll find that the voltage across the capacitor has dropped to 36.7% of the 2.5 volt, which is basically about slightly less than 1 volt.